Hello guys, welcome to Code Decode. Today we will discuss the differences between JVM, JDK and JRE. So let's get started. Okay, before jumping into the internals of Java, let's understand how exactly the Java source code file is executed. Whenever you write the Java source code file into simple.java file using an editor or like for example Eclipse or a Spring Tool suite, program has to be compiled into bytecode and Java compiler is responsible to convert your source code into simple .class file. This .class file can be executed in any platform or operating system by JVM. So you can see that the .class file is platform independent. Consider there are two platforms, Linux and Windows, and you have single .class file. So you can use the same .class file in both Windows and Linux. It will get converted into the same machine code. But here comes the twist. For both you need different JVM. So JVM is basically platform dependent. But if you see the whole Java is platform independent. Why? Because when you convert the .java file, it get converted into the .class file, and when you convert the .class file into machine code into different platform or operating system, it get converted into the same executable machine code. Let's understand more with the help of this picture. Okay, so first simple Java source file is get converted into the .class file using the Java compiler, and this .class file, which is platform independent, gets converted into executable machine form by JVM. JVM is basically platform dependent, so that's how Java works. It is basically the two-step process. First, the file get .java file get converted into the .class file, and .class file get converted into the executable machine code. Whereas in other languages like C and C++, the process is only one step. Your source code file get converted directly into the executable machine code. So this is also the reason why C and C++ is slightly faster than Java. Although Java has compensated this speed difference a bit, and I'll discuss this more into the next slides. Okay, so let's come to the next topic. What is JDK? JDK is a superset of JRE. JDK contains everything that JRE has, along with the development tool for developing, debugging, and monitoring the Java application. You need JDK when you need to develop Java application. So basically, you need JDK when you are a developer. Same as JRE, JDK are also platform dependent. So please make sure to download the right version of JDK package for your machine, because there are different packages for Linux and there are different packages for Windows, because JDK is a platform dependent. So let's jump into the next topic. What is JRE? JRE is a software package that provides Java class libraries along with the Java virtual machine and other component to run application written in Java programming language. JRE is basically the superset of JVM. If you need to run Java program but not develop, then JRE is what you need. So basically, if you are a tester and you don't want to develop any kind of program, only you have to run and test that program on ad hoc basis, you need JRE. The following steps take place at runtime. That is basically the class loader, bytecode verifier, and just-in-time compiler. I'll explain this topic in the video of the architecture of JVM in deeply. Let's understand the difference between the JDK, JRE and JVM with this diagram. So basically JDK is JRE plus the development tool, as you can clearly see in the diagram, and JRE is the JVM plus library classes. Let's understand the JRE into much deeper. So inside the JRE there is JVM. So JVM is a Java virtual machine. Java virtual machine is the machine that runs the Java bytecode. It basically converts the bytecode into the executable form, which you can run on your machine. You get this bytecode by compiling the .java file into .class file. .class file contains the bytecode understood by JVM. So the question arises, why you need JVM? You need JVM because when you convert the .java file into the .class file, you need something that which converts the .class file into exe file. or your machine executable file. So here JVM come into the picture. One more importance of JVM is when you see the coding standards or coding process in C or C++, it's a one-step process. And when you convert the C code into executable form, you have to convert that code into executable machine form each time for each platform. For example, you have to convert the source code into the executable code on Linux, and you have to convert the source code into the executable code on Windows. You have to do for two times, like one time for Linux and one time for Windows. But in Java, all you have to do is you have to convert the source code into the dot class code, and that dot single one time, and that single dot class code can be run into Linux, Windows, and any other platform via JVM. So JVM is platform dependent, but that dot class code is platform independent. So basically bytecode is platform independent. So let's conclude this topic of JVM, JDK and JRE using this picture. So we have a .java file which get converted into .class file using this JDK, which has Java compiler. So that Java compiler compiles the .java file into .class file, and this .class file get converted into the .exe file using the JVM. So basically JVM JRE contains the JVM. So JRE is the superset of JVM, and JRE contains JIT and JVM. So what JIT does is JIT along with JVM converts the .class file into executable machine form. So why we need JIT? So there are some codes like if else condition. So there are a bunch of codes which need to be converted directly into the machine executable machine form. But what JVM does is JVM is an interpreter. It converts the code line by line. It read each line and then convert it into the executable machine form. So it read each line of bytecode and then it converts into the executable machine code, which is actually a time taking. So to fasten the process, Java introduced just-in-time compiler. So it executes the bunch of code along with the JVM, which is an interpreter which converts the code line by line into executable machine form. So they both work in synchronization. So this is the way that Java fasten the process of converting the .class code into exe code. So guys, that's all for JVM, JDK and JRE. Stay tuned for other videos.